Well, hello.
Ahoy.
Lecture video number 6. Unit conversions. I love me some dimensional analysis.
When I was in high
I'm the
school,
math guy,
this was like the first thing my chemistry teacher taught us for the first week of school because it got a lot of the kids that weren't supposed to be in the class out. But that was 15, 20 years ago, and the need to do unit conversions in chemistry has come down a little bit.
It has.
We're really going to focus on the one specific area.
Yeah, grams to moles, moles to grams.
That you need to be able to do this for.
Right.
Instead of every single unit, inches to feet to miles. But the fact is this technique that we're going to show
Works across the board.
Anything. I can convert nanograms to tons using this technique.
Right, you can go from inches to miles.
I could go from seconds to years.
Yep, you could.
Right? How old are you in seconds, Mr. Milks?
We could make you figure that out.
With this exact technique.
It will work every time.
But we're going to focus on the grams to moles, moles to grams. That's it.
Sure. But there's going to follow this particular format, which is the given units times the conversion factor that we need to learn how to set up. Gives us our wanted units. We set up that conversion factor, right? The math takes care of the units.
Some teachers call this unit cancellation.
Some do.
We call it dimensional analysis because that's the way we were taught it. That's what it is. If
Yeah.
you went and did a Google search on this technique on YouTube and stuff, dimensional analysis or unit conversion factors would find you more examples.
Sure. So we learned how to do gram formula mass last video. So hydrogen's 1, and there's 2 of them, so that's 2. Oxygen is 16. Add that all up, and water becomes 18 grams per mole.
Right, and this is video 5. How do we figure out the mass of 1 mole of water? We did this.
Right.
We found out that 1 mole of water weighs 18 grams.
Right, I just did it real fast.
We could put it on a scale and weigh it and say, that's your mole, Mr. Milks.
Right, now we know how many particles or molecules of water were in there.
But now we're going to start to use it to convert between. We're going to show you how you can flip this conversion factor up and down.
Well, right, and this is the mathematical property we're going to play with because anything divided by itself is 1. And if 18 grams is 1 mole, then they're equivalent.
Mole is 18 grams.
So it doesn't matter which way I write them, they are equivalent statements.
And so remember the division sign here is us saying per.
Yes, per does mean
18 grams per 1 mole or 1 mole per 18 grams. It's the same way of counting, just flipped on its head.
Right. So here's the process. Process is just let the units be your guide. You're going to hear us say that over and over and over.
So the problem is going to ask you how many grams is blah, 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 blah. So you need to know to convert it into grams. So you're going to find the units from your problem that you have to convert into at the end. And that is how we're using it to be our guide.
Right. And then we just saw 2 examples of unit conversions where it could be either or.
Right.
And we want to pick the one that has the denominator unit in the units that I'm given.
Right.
So if I'm going 2 grams, if I'm in moles going 2 grams, I want to pick the one with the moles in the denominator.
And the grams in the numerator, because that'll become your new units, as you'll see.
Let's try it out.
Check it out. So moles to grams, you always have to have your gram formula mass.
Yep. So there's this tool we learned earlier.
2, start with what you're given. In this case, if you're given moles, so 5 moles of oxygen, how many grams does that weigh? That's the type of problem. Multiply by the gram formula mass as your conversion factor and with the moles in the denominator. So the units will drop and change.
Right. So the number of grams will be in the numerator. It's always per 1 mole, too. That's something else we might not have said. Gram formula mass is always per 1 mole.
Right.
So that number is easy because dividing by 1's easy, multiplying by 1's easy.
Yeah.
That's a nice little trick in there.
Let's get to some examples here. But here's how you do liters of gas.
Liters of gas.
Because remember, from Avogadro's mole theory, 1 mole of a gas
is 22.4 liters.
Exactly, every single time. So start with what you're given, in this case liters. So 15 liters of a gas, how many moles is it?
Right. And if you see the way I wrote that in there, 22.4 liters per 1 mole, but then I say with liters in the denominator. I'd have to actually flip that
1 mole on top,
so that I get rid of my
liters on the bottom.
We do some examples. I think this will make a little bit more sense.
Now to get from moles to grams, this is how we're going to do it. And first we need our gram
gonna write
formula.
this down?
Do you don't mind?
Yeah, no problem.
Hey.
So we're going to start with what we're given. So write 15 grams of lithium because that's what I'm given. And I look at my periodic table. Lithium is 7 grams per mole. And I want to put the grams in the denominator specifically because here's the other thing that we like to do a lot mathematically. We're not going to cross multiply this, okay? We have to multiply numerators across, then multiply denominators across and do it. And what ends up happening is you get grams times moles over grams, and then the grams cancels. And Mr. Monaco knows that the grams going to cancel because of that. And so we're good. I get 15 effectively divided by 7, which is 2 point something or other.
So, yeah, you can do it.
In
15
my
divided
head?
by 7, 15 sevenths.
In my head, yeah.
Yeah,
Right.
you
So
can
it's
do it on your
0.12. You got it.
Right.
Put it in your calculator.
Mm-hmm.
But that's how we do it. Okay,
And so
good.
see how here now our final units.
Is in what they asked for, and it's what the question asked. So there's the reading comprehension piece. It says how many moles. My answer had better be in moles, units being my
Guide. I saw what I needed to get to. I set up my conversion factor so I got there. That's what this is about.
That's what this is about. So let's erase that. We got one more with liters.
Okay.
Or a couple, 2, 3 more. So how many grams are in 4.5 moles? So now I'm going to start with moles, because that's what I'm given. And of course, we actually wrote that we need to find the gram formula mass first. And in this case, that's a little bit more complicated because I got Na and I got F. And I know that Na weighs 23. And I know that fluorine weighs 19. So it's going to be 23 plus 19 is 42 grams in 1 mole. And we set that up with the grams in the numerator so that moles are in the denominator and moles cancels. So now it's effectively 4.5 times 42. That's my answer. And I need to plug that into the calculator, and I got my grams. And let the units be your guide. I have grams left. That's what I want.
And you can put grams on a scale.
I can put grams on a
And
scale.
that's the point.
That's the point. I think we might have one quick one with liters.
Yeah.
It went away. Cool. So, volume of 1.2 moles of water. Well, I'm going to start with moles of water. I have 1.2 moles of water. That's what I'm given. And I know moles has to go instantly in the denominator. So 1 mole of water should be 22.4 liters because it's a gas at STP. So all gases are 22.4 liters. We learned that on a previous video. Moles will now cancel. And it's simply 1.2 times 22.4 liters. And we have our answer. Again, I don't want to see 1.2 times 22.4 written in your practice packet.
Do it.
I want to see the answer written there. Gabishki?
You do the math.
Okay. Oh, that time it didn't go away. Have fun. Weird. I guess we got one more.
Yeah.
How many moles of argon atoms are present in 11.2 liters?
Because we're going upside down. We're going
Yeah,
backwards.
cool. So I'm going to start with 11.2 liters because that's what I'm given. I want to get to moles, which Mr. Monaco just circled so nicely for us. So I need liters now in my denominator. At STP, there is always 22.4 liters per 1 mole, and I'll have 1 mole up top. And I can see just by this math, this is 11.2 divided by 22.4 essentially, which is 1/2.
Yeah.
Okay. So we're good.
Yeah.
Got a 1/2 mole. If I got half,
And we want to see a half as your
11,
answer.
right. If I got 11.2 liters, then I got a 1/2 mole
Yep.
of any gas.
Yep.
But this unit conversion works out. I hope those are enough examples
Mhm.
so that you can now go to the practice page, start working on some of these. You got two or three pages of this plus a homework video lecture.
Yep.
Hi.
Thanks for watching. That one. I got to click on the right stuff.